Welcome to the lecture for Psych 350. We'll be talking about the biological approach to understanding personality, and similar to trait theory in some ways, in that it's not dominated by a particular school of thought, and there isn't a psychotherapeutic approach based on this approach to understanding personality. And it's not even really a theory, but just a way of looking at personality based on the assumption that individual differences in personality can be explained in part by biological differences among individuals. That being said, there is an early theorist that was influential in applying biology and kind of an understanding as biology as etiology for personality, and that would be Hans Eysenck. And Eysenck's theory, which we've talked about before when talking about factor analysis. Right, he came up with a three-factor solution, talking about extroversion, introversion being one factor, neuroticism being a second, and then in his later work, a third factor of psychoticism. So you have these three factors, which he referred to as super traits, and beyond this, he also, in his theory, talked about this kind of hierarchical structure of personality with these super traits at the top of the hierarchy. But to kind of really understand the hierarchy, it's probably better to look at it from the bottom up. So at the bottom of the hierarchy, at the simplest level, would be your specific responses, right? So these are just observable behaviors. So, for example, you might see a person driving well above the speed limit. Like, well, that seems dangerous. But you see them do that one time, two times. That's a specific response in a situation, right? And if you see that person engage in a specific response multiple times, so multiple times or in multiple situations, so speeding in a school zone, speeding on the highway, you saw them on Monday, Tuesday, Wednesday, Thursday, and Friday, whatever. Now that specific response is a habitual response. So specific responses that are repeated multiple times or multiple situations are then deemed habitual responses. And not all specific responses will be habitual responses, but all habitual responses are made up of specific responses, right? So if you just speed that one time, then you don't have that habitual response. You just did it one time, you were running late, whatever. It's not something you do habitually. But if it is, it rises to that next level. And then even above that, are traits, and traits are when you have related habitual responses. So you have these habitual responses, one of which might be driving fast, and then some others that might be related to that, juggling chainsaws, having sex without condoms. All these related habitual responses might imply an underlying trait. Okay. So for the one example we're talking about, the trait would be risk-taking, right? So there's different ways to engage in risk-taking, and those different ways of engaging in risk-taking are the habitual responses. Okay. And then Eysenck went beyond that. Other trait theorists may have stopped there and said, okay, you're at a trait level. He said, no, I can even organize these traits into super traits, right, which were one of his three factors. And so a super trait is whenever you have related traits. Those related traits imply an underlying super trait or factor. So for the trait of psychoticism, you have, for the super trait of psychoticism, you have the underlying traits of, or the supporting traits of risk-taking, impulsivity, irresponsibility, manipulativeness, etc. There's a couple other ones. We won't go into all of them. But all those things go together to make up psychoticism. Okay, so far, as we've kind of talked about Eysenck's theory, it's just a trait theory with kind of this added hierarchical structure built in. But we're talking about Eysenck in this chapter because of some other things he talked about. One of which saying that he proposed that the differences in the degree to which individuals demonstrated the super traits were related to differences in their physical makeup, and different differences for different traits. But for example, looking at level of extroversion versus introversion, he proposed that people who were high in extroversion had lower levels of cortical arousal and people high in introversion had high levels of cortical arousal. And we're talking about cortical arousal, we're talking about activity in the cortex of your brain, the front top part of your brain that does most of the upper level thinking, and that we think of as the personality part of your brain. People that had kind of high levels of activity there versus low levels, that would relate to introversion, extroversion, and the idea being roughly that people are driven to experience more or less arousal. So if you have high levels of arousal, as he thought people who were introverted did, you'd be driven to seek out experiences and act in ways that would decrease the arousal. So you would prefer to spend time alone and you would withdraw from social situations. But if you had low levels of arousal, you would then be extroverted and you would seek out more stimulus, social and otherwise, to increase arousal to an acceptable level, which is a biological explanation for differences in personality. It was interesting, but he was wrong. There's no evidence that people who are deemed extroverted or introverted have different levels of baseline cortical arousal. But he kind of set the people on the trail, and they found that although there are differences in kind of baseline cortical arousal, there are differences in physiological sensitivity. Right? So people seem to differ depending on how introverted or extroverted they are, and the degree to which they are sensitive to various stimuli, with generally introverts being more sensitive. So the logic still applied where, okay, so they're kind of hypersensitive to stimuli, so they want to reduce the stimuli they're taking, and extroverts being less sensitive, so needing more stimulation to get a level of arousal. But assuming the same baseline arousal at the beginning, but different levels of sensitivity to experience any change. So some support for that basic idea, and then beyond that, there's been other research looking at the BAS in BIS, right? Which we're talking about the behavioral activating system and links between that and extroversion, and the behavioral inhibition system as linked to the trait of neuroticism. Now these systems they're hypothetical systems. They're basically neural pathways involving different parts of brain structure and sometimes glands of the endocrine system. And the idea being that the way you're wired in these parts of your nervous system and your kind of hormone system is related to how extroverted you are for the behavioral activating system, which is kind of a theoretical system that guides you toward approaching stimuli, and the behavioral inhibition system, which is the one that is associated with kind of anxiety and withdrawal and pulling away, and that being more related to neuroticism. But again, those are hypothetical systems, and the debate about exactly what role those systems play and what comprises those systems is ongoing. So some support for this idea of a biological explanation for differences in personality, but it's not clear-cut. It's not unequivocal. Okay, but Eysenck kind of got things started, and then beyond that, much of the support of a biological basis for personality comes from research on temperament, right? And temperament is basically a broad behavioral disposition, which is not the same thing as personality. It's like personality as a concept, but maybe less refined in some ways. So more broad, less specific. So generally doing this rather than being extroverted versus agreeable versus conscientious. Right? But it's important to study. One of the reasons why it's important, especially for the biological basis of behavior, is it's evident in the first year of life. Oftentimes, by the age of 3 months, you can reliably classify babies as being one type of temperament or the other. And because of the early identifiability of temperament, it's thought to be genetically influenced, right? With the idea being, well, they're too young to have had much environmental input, which there is something to that argument, but I think sometimes people forget that your environment doesn't start at birth, right? You have a intrauterine environment. Your brain is developing and developed before you are born out into this world, and you are being influenced by some degree external stimuli, but certainly exposure by to hormone levels in your mother and whatnot. So there are some early environmental experiences. So the idea that whatever you have when you're born is all genetics, it's a little bit of a misunderstanding in ignoring early environmental influences, intrauterine environmental influences. Nonetheless, still it's taken as evidence of genetic influence, and paired with other studies looking at similarities across families, looking at twin studies, it does seem there's pretty good evidence for a strong genetic component to temperament. Okay, so agree about that, but don't disagree so much about the factors, about what temperament is. Right? So in general, most researchers agree that babies are different from each other in predictable ways, but they don't agree on how to describe these differences. One way would be, say, looking at their degree of emotionality, sociability, and activity, looking at these at all three of these being continuums. With emotionality, looking at the intensity of emotions. When they cry, do they cry really hard? When they laugh, do they get really excited and laugh really loud? Sociability, having to do with their interest in interactions with objects and people in their immediate world, and activity, just related to kind of a general energy level, high energy versus low energy babies. Another way of looking at it would be well-adjusted versus uncontrolled versus inhibited. So well-adjusted means you're kind of happy, easygoing babies who do fine in response to changes in schedule. Uncontrolled, you can kind of hear the Freudian influence there. It's kind of unchecked id impulses, right? Where they are hard to satisfy. When they're hungry, they cry, and they can't manage themselves in any way. And then the inhibited being one of the more interesting pieces of temperament, because it's one of those aspects of temperament that really shows some strong stability into adulthood. And when we talk about inhibited, we're talking about kind of this experience of anxiety in the face of novelty. Whenever there's new things, they're like, I don't want to check that out. I'm going to wait and see what other people do and if it's safe. Versus uninhibited kids, like, oh, new toy, what's that? And they'll go play with it, or hey, look, a snake, and they'll go pick it up. So good and bad to being inhibited or uninhibited, but that kids that are inhibited as infants, there's some longitudinal studies suggesting that as adults they will be more social anxious than adults who were uninhibited babies. So some strong evidence of stability there, which again, when you see that level of stability, a lot of people say, well, that appears to really argue for genetic influence, with the idea being that your genetics are fairly stable. They're not written in stone, and they do respond to environmental inputs, but they are fairly stable, more so arguably than are your environment. As you get older, your environment changes significantly. From little things, from sitting in a high chair to sitting in a regular chair. That's a significant environmental change. So your environment changes as you grow older. Even if you live in the same house all your life, it's still a different environment as you're growing older. People are interacting with you in different ways as your abilities change. Okay, so they can't agree on the factors. These are two examples of ways of talking about it. There are several others. And they're not all kind of three-factor solutions. Some are five, some are more. But generally, it's about three. But one of the more interesting things about temperament is the degree to which it seems to interact with environmental inputs. And there are a couple ways that this happens. And one would be when we talk about these passive gene-environment correlations. And a passive gene-environment correlation is simply talking about when a child's genotype, so the genetic inherited temperament and his or her environment are related, they're correlated assuming that the child lives with his or her biological parents, right? So imagine a kid gets the inhibited genes, right? So gets this genes from the parents that would make them more likely to be inhibited versus disinhibited. Well, who'd they get the genes from? Well, they got from their parents. If they got inhibited genes from the parents, unless these passive genes, their parents were likely inhibited as well. So these parents will also model shyness and maybe some anxiety in response to novelty. So there's a correlation between the environment and the genes. So when the kid shows up as inhibited, it's like, well, is it the genes or is it the environment? I don't know. They were both. They're related. And there's these evocative gene-environment correlations as well. And this is the idea that a heritable behavior evokes a particular response. Right? That's the evocative. It evokes or pulls for a particular response from the environment. Right? So a kid that's inhibited and shy, well, how do you react to that kid? You say, okay, well, I'm going to leave you on your own. You go do whatever. Here's some money. Go down to the store and give me a 6-pack of Cokes. No, that kid, they're shy. You're not going to let them do things by themselves. You're going to shelter them because you think, oh, well, they're shy, they're scared, I better stay close. And so the more you stay close and don't let them go explore and possibly take some risks, the more they'll stay that kind of shy kid. Right? So the stuff they're born with pulls for an environment that supports that temperament. And then there's the third type of gene-environment correlation to talk about would be active gene-environment correlation. And this is just kind of noting that heritable characteristics might cause the child to seek out environments that fit with their inherited trait. Right? So this is not necessarily just the environment reacting to the kid's trait, but a shy kid seeking out an environment that supports shyness. So seeking out solitary activities that are rewarding. Right. So I'm going to try to learn to read early because I can do that by myself and don't need people to be around me, and it's fun and enjoyable. Right. And then they have these rewarding activities which reinforces shyness. Hey, this isn't so bad. I enjoy being here by myself. Right. So we have all these different ways that genes and environment interact. That temperament interacts with the environment. And one of the kind of interesting things about this is that throughout these interactions, temperament seems to, in general, provide a range of possible outcomes. Right. So if you get the super inhibited genes, you're probably not going to be a super outgoing person. But at the same time, genes aren't destiny. Right, so two kids born with the exact same genetic load for being inhibited, same level of shyness, they might be very different in how shy they actually are, depending on those environmental inputs. To a degree, right? The environment can move you along that continuum and push you to be less inhibited, or it can push you to be even more inhibited than your genes would merit. Right? So think about the temperament providing this range, and within that range, the environment will cause or may cause different shifts. Okay, so another biological perspective, slightly different from genetics and temperament, but still related to genetics, would be the evolutionary personality theory, and this is based largely on originally Darwin's work in whatever the guy's name who didn't get credit. I feel bad, I can't remember his name now. But unnatural selection, right? Which the idea that applied to personality, that personality traits that were adaptive were passed on from generation to generation, and the people with maladaptive traits did not pass on their genes. Based really on kind of two mechanisms. One being kind of the survival of the fittest, right? So this is all about personality traits that allowed you to live and not get eaten by or stomped on by a woolly mammoth or fall off a cliff. Those things, those traits got passed on. So people who were afraid of snakes, they lived and they passed on their genes. People who were really super high in fearlessness and had just no fear, they thought they could jump off a cliff and be fine. They didn't make any babies, right? So they didn't pass on their genes for fearlessness. Some level of being fearful was adaptive, and people who were to some degree fearful lived. People who were too fearful to leave the cave, well, they didn't get any food probably, and so they may not have lived. So the idea that there's some range of emotions, and those that were adaptive got passed on, and the ones that fall outside of the range of adaptivity, those people didn't live to pass on their genes. But more than that, so more than just living, right? To pass on genes, you don't just have to be alive. You got to make babies, right? So we also have sexual selection, and this is often used to account for gender differences, which is a controversial topic. So it's not just about surviving, but also about procreating. So traits that allow people to mate were passed on. And so people who had traits, who had personalities that got in the way of hooking up, didn't have any babies, and so they didn't pass on their traits. And it wasn't like people think, wow, I really want to pass on my genes, so I'm going to try to be really charming and have lots of sex with these people. No, people who wanted to have lots of sex and who were really charming had the sex and had the babies, and they passed on their genes. They weren't trying to pass on their genes, it just happened because that's the result of having sex. One of the results. Okay, so this combination of survival of the fittest and sexual selection was thought to have shaped human personality across time, right? Not just from one generation, but over many generations, thousands of years. And in some ways may continue to work. In some ways, modern advances in technology may have short-circuited to a degree the impact of evolution on personality, because some of the pressures for mate selection and survival that may have formerly existed don't exist, or at least they're certainly different now than they were before. So it's an interesting theory, right? But there are some problems, especially with the stuff looking at gender differences. You know, one of the things that is probably most controversial is the one people use evolutionary theory to justify infidelity on the part of men, and saying that, you know, well, men are genetically programmed via evolution to spread their seed far and wide, with the idea being that men who had sex with lots of partners contributed greatly to the gene pool. So all these genes connected to the Y chromosome that are related to not being monogamous got passed on, and that's why men are that way. And that has been criticized on a number of grounds, but one of the main ones is just the idea that, you know, there's no way to really test that, and also we can think, well, if the opposite were true, we could probably justify that with evolutionary reasoning as well, right? If men were completely monogamous, we could logically say, okay, well, that makes sense given evolution, because the men who were monogamous were able and didn't stray too far from home were better able to provide for and protect their families, and therefore their children were more likely to survive, and their genes were more likely to be passed on. Right? So if you can have two opposite outcomes explained by the same theory, it's not a falsifiable theory. So very problematic in many ways, but nonetheless an interesting way of thinking about personality development, but it certainly has some limitations. Okay, in terms of application of the biological approach, one of the main areas that has been applied, especially with regard to temperament, is in the school systems, and understanding that assessing children's temperament, having a better understanding of what a child's temperament is, might be beneficial in a school setting. And part of the reason for that is there's an abundance of research suggesting an association between academic performance and temperament type or style. And again, depending on how you're measuring temperament, it's kind of hard to look at all the studies because they define it differently. But in general, certain temperaments, kids that fall into certain categories, seem to do better in a traditional classroom than other kids. Other kids struggle, and then some kids somewhere in between. But it's not necessarily that, okay, well, you know, this temperament is what makes a kid smart, right? It's not about some sort of association with intelligence. It's about the goodness of fit, about the fit between the temperament of a child and the expectations of a school setting. And one of the reasons we know about this is there is some variability in school settings. We think of one easy example would be kind of your traditional public school setting, where you have language arts in the morning, and then math before lunch, take a break, come back and do social studies, right? So you do subject, so everybody's on the same page, everybody reads the same books. Compare that to a Montessori approach, and there are a lot of different Montessori approaches, but in general the idea of Montessori being more self-paced, self-stimulated learning, where kids can move from one task to the other at their own pace. In some kids' temperament fits that traditional model better, and some kids' temperament fits this Montessori model better. So ideally, in our public school system, we would have kind of individualized education plans for every child. We would measure their temperament, figure out the best way to teach that child, and then implement a course of action consistent with that. Unfortunately, especially due to recent budget cuts, that's just not ever going to happen. Not economically feasible. Happens for kids that once they struggle enough, you get an individualized education plan, right? Well, some kids do. But for most kids, that doesn't happen. If it did happen, maybe our test scores wouldn't be as far behind other countries as they are. So, research may have something to say here about that could be useful. Well, it's nice when that happens. Some other interesting stuff, looking at cerebral asymmetry, and this is looking at EEGs, electroencephalograms, and the relationship between brain activity, right, and the right and left hemisphere. The idea being that it's not the same. The level of activity isn't symmetrical; it's asymmetrical. Sometimes it's higher in the left, sometimes it's higher in the right. And in general, higher activity in the left hemisphere seems to be associated with approach emotions, emotions where the emotional experience serves as a motivation to approach the object that's causing the emotion. So oftentimes we think of kind of happy emotion. That's something that makes you happy. If you're happy, you move toward it and to seek out more happiness. But anger is also an approach emotion. It's like something really makes you angry. You don't typically run away from it. You approach it to make it stop making you angry. Whereas the right hemisphere activation seems to be more associated with avoidance emotions, emotions where that motivate you to get away from the cause of the emotion. So anxiety being one of those, where the general tendency, if there's a big scary dog chasing behind you, and you experience anxiety, you don't think, oh, I need to run to that dog. You run away, right? So your right hemisphere is probably going nuts at that point. So we know that if we manipulate your emotions by showing you, different movies or having you read different poems, different stimuli designed to make you experience certain emotions, we can see differences in right and left hemisphere activity. But more interesting than that, for personality researchers, there seems to be fairly reliable individual differences in your resting level. So when you're not being chased by a dog or super happy, just your kind of typical sitting in a lab with electrodes hooked to your brain, which hemisphere is more active, there seem to be some reliable differences, which might suggest a difference in kind of your proclivity to certain emotions. People with higher left hemisphere activity would be more prone to experience those approach emotions, so more prone to experience joy, but also more prone to experience anger. And the ones with right hemisphere, more prone to experience maybe anxiety and depression. Okay. So we've got this kind of correlation between personality, emotion type experiences, and kind of biology in the lab stuff, which is always interesting. we usually think there'll be more than we found, but that's one thing that they found, which is interesting. Okay. So, the other thing there. Evaluating the biological approach. One thing it's done is helped us kind of get rid of this idea of the tabula rasa, right? The idea of blank slate, that kids come into the world and they're a blank slate, and we can mold them and make them into whatever we want. No, you can't. How much can we mold kids? Debatable, but there does seem to be a limit practically on how much kids are molded. Right? Nobody yet has given scientists free rein to, take babies from birth and subject them to controlled studies to see if they could make them, criminals or presidents. Unfortunately, but there does seem to be, based on all the research from the biological approach, that you are born with some predispositions. And again, it's not determined how you're going to be, what your personality is at birth. It's not predetermined. But there are dispositions, there are leanings, one way or the other. And the leanings can be bent, but they usually can't be reversed. Okay? The leanings are usually vague enough that it's not like any kid is born evil or hopeless. So there's good news there. One of the things that I like about the biological approach is that it is pan-theoretical, so it encompasses multiple theories, and multiple other theoretical approaches can cite the biological approach. Depending on how you conceptualize things, you can think, okay, well, a trait theorist saying, okay, there are these different traits. And how do you get those traits? Oh, it's biological. But you could just as easily see kind of a neo-Freudian talking about defense mechanisms, saying, well, you have these different defense mechanisms, and which type of defense mechanism you prefer is influenced by genetic predisposition. Right? So the ideas of this biological approach really can fit into a lot of other theories. One of the things I think you have to be careful, though, is sometimes there's what I call a language data mismatch. In terms of the language that is sometimes used by authors from biological approach. When you read it, if you just kind of take it at face value, you think, wow, they've really got it all figured out and they can explain everything. And usually they can't explain everything. Sometimes their claims, their conclusions aren't as measured as they should be. You say, okay, well, we found this. We can explain this personality trait is highly heritable. Therefore, shyness definitely is completely biologically determined. And you go back and look at their data, and well, they couldn't explain differences in shyness for over half the people in their sample, but still they deemed it highly heritable. So you have to read the fine print when reading this stuff, and think about carefully about what their studies are measuring, and if you agree with them when they say what they're measuring, because sometimes I think there's a tendency to overstate conclusions in this area of research. Similar to trait theory, also a lack of unification. There's no it's good and bad. There's no dominant theorist out there who owns the biological approach, not named after anybody. But at the same time, as we see with kind of the sub-area of temperament, there isn't an agreed-upon conceptualization of what temperament is or how it should best be defined or measured. So some lack of unification is difficult, at least in terms of trying to understand the approach. But it's probably helpful in terms of lots of people working from lots of different angles will probably get us closer to the truth than everybody jumping on the same boat going the wrong direction. And then last, something we've already addressed, are the problems with evolutionary theory. Really lacks the theory itself, it's kind of intuitively appealing, but at a scientific level lacks some important aspects of being a scientifically valid theory. And so, again, some of the writings there pretty clearly biased in terms of male authors writing, justifying bad behavior by men. Okay. But overall, again, kind of like trait theory, something that's just become part and parcel of research, and it's just kind of assumed that, yeah, things are genetic influence and inherited, and now the argument's about, well, which things and in what way. So which genes and how are those genes expressed? Obviously that's not the genes for your fingernails, so it's the genes that influence the functioning of the hypothalamus or of the amygdala, or what what is it about the genetic influence that's causing people to act in consistently different ways. Okay. That's all for now. Take care.